Hello, I'm Martin Appleby, and I will be your guide to the PCWG GUI version 0.57. For those of you who have met the tool before, this will be very familiar to you. For others, I will try to cover as much as possible to give you a good overview of the tool. For this demo, I will be constructing from scratch an analysis within the tool, recreated from the originally named Res Benchmark Dataset 1. Welcome to the Graphical User Interface, aka GUI. This primary screen is the console, which will update you on the status of your calculation as it's running, and as you format the inputs. I will start with demoing the creation of an analysis configuration file and dataset config file, followed by a run of the calculation and report generation. The GUI, as shown here, allows you to load and edit existing files, as well as to create new ones. This is the analysis interface. It contains the primary settings for the calculation. Most of the settings have a default or can be left blank. However, anything with a red tip message, as shown, has to be entered by the user before you can save. For now, we will leave general settings and power curve bins as they are, and I will come back to dataset configuration in a moment. The inner range defaults are too low for my calculation, so I'm going to have to update them. Similarly, in turbine settings, the rated power and the hub height are too low. I also need to enter a specified power curve, or I will not be able to save. Turbine and roost corrections can be activated here. I don't need to select a specified power deviation matrix. I'm also going to leave the advanced settings as they are, as I don't have a nominal wind speed distribution file, and my baseline mode can be set to hub. Before you can save the analysis config, you have to add a dataset. This can be done by adding a pre-made file, or by generating a new one. After naming my dataset and selecting an input time series path, I can tell the tool how to read my file by choosing a column separator and by telling it the number of rows to skip before my header. I can also add a start and end date. This date picker allows me to pick a date that is valid. If I pick one outside of the range, for example the 45th day of the 13th month, it will throw an error. I will now set my hub wind speed mode to specified and my density mode to specified, but leave calibration method as none. Because of these settings, I don't need to change my reference wind speed setting. Next I will show measurement and power settings. I don't need to change the first two values, but I do need to update my date format so it matches the time series input. I also need to choose a timestamp, or I won't be able to save my dataset. Because I set hub wind speed mode to specified, I need to select the data here. Similarly, this applies to both turbulence and density. If I don't select a power value here, I won't be able to export reports at the end of the calculation. However, min, max and standard deviation can be left blank. As said before, I don't need to change my reference wind speed settings because I specified this earlier. The user can input any number of shear measurements and roost profile levels in the GUI. For each shear and roost profile level, a height and wind speed needs to be added. However, for roost profile levels, a wind direction can also be specified. The measurement can then be edited or copied across. However, the wind direction is always set to default, so it does need to be manually selected. The number of rotor levels is also inputted, along with the ruse rotor mode and the hub mode. In this example, I only had 2 shear measurements, but I have 9 ruse profile levels. This shows that the user can input as many ruse profile and shear measurements as they like. In this example, I don't have any calibration, exclusions or filters. However, I will set them up just as an example. In calibration settings, you can set a start date similar to the date picker shown before, as well as the number of sectors and the center of the first sector. In calibration sectors, you can then set the direction, slope, offset, and whether or not this calibration sector is active. These default to 0. In filters, you have the column, value, calibration filter type, and whether it is inclusive and active. For the column, you then have to pick similarly to the previous settings. Exclusions run on the same date picker as in calibration settings and in general settings. The filter selection box is almost identical to that of the calibration filter box, including value, filter type, inclusive, active. Once you are finished with your dataset, save it by pressing OK. I can now save the analysis config as well. This allows me to run the calculation. Once the dataset has been created, we can run a calculation. The console will keep you up to date with status messages. As you can see, I've now finished a calculation. Now I can export reports, anonymous report, and time series. If I was to export a report before the calculation, it would come up with an error message in the console. Similarly, if I did this for either report or anonymous report, and there was no power setting, I would also get an error message. In anonymous report, if turbine correction and ruse correction aren't active, it will also not run. Finally, I can also export a time series after the calculation. Once all this is complete, I will show you an example of the graphs created and the reports. Here are the examples of the graphs created for my dataset. There's turbulent winds, power curve, and power curve with reference TI. I also have example the report, which shows overall all of the output data. It also has all of the data put into the GUI. The anonymous report shows the specified power curve, and the time series shows all of the input data. Thank you for watching. I hope this has been helpful. And for more information, please visit www.pcwg.org. Thank you.